Hey guys, okay, so today we're going to move on and we're going to talk about solving inequalities. So, this is the last kind of concept that we're going to learn before we take our Unit 1 test. So, we're going to cover solving inequalities today, and then when we come back from Labor Day, we'll talk about it. We'll go over it a little bit more. We'll practice some more, and then we will review and we will take our Unit 1 test. So, probably on that Thursday after we get back from Labor Day. So, probably about 1 week. In exactly 1 week, we're going to have our Unit 1 test. So that'll be our first major grade of this 9 weeks. So the good thing about solving inequalities is that is almost exactly like solving equations, except there's one little piece you have to remember, and I put it in this green box right here. And so we'll talk about that too, where you have to flip this symbol. And you guys, hopefully that'll come back, because I know you've been solving inequalities since like 6th grade. And so ours just have a few more steps. So here's what you're going to do. I'm going to actually switch over to my iPad, but where I write, you're going to type here, and then I'm going to draw these number lines, but you're going to drag over the ones that look like the ones I draw, okay? So that's how you're going to work on your slide. So pause the video as you need to and fill in. I'm going to go over to my iPad now. So linear inequality. So here are our inequality symbols right here. So let's actually talk about and review, what do these symbols even mean? Well, if you see this symbol right here, this one is what we call I'm going to write them down here, less than, okay? So it's like saying if we had a number over here, or we usually have our variable first, x less than, let's just pick a number 3. Well, if x is less than 3, that's how we would read it. So you can read them both ways, actually. Sometimes you have your variable on the other side, and then you could still read it from that direction. So you really just start with your variable and read them that way, but we'll talk about that a little more too. So this is less than. Now you don't have to put the x and the 3, but I want you to type the words. Okay, so let's graph that. What does that look like if I graph it? Well, if I draw my number line, and I know usually y'all put like 0 and then, but you don't have to do all that. Just put a line, mark where the 3 would be. So if 3 is there on our number line, you don't have to put all the other numbers around it. We get the gist. So if x is less than 3, so what this means is strictly less than. So I would draw an open circle because I can't include 3. It says x has to be less than 3. It can't include 3. And I would shade everything on this direction because those are all the numbers on the number line that are smaller than 3, right? So we have to remember which direction do we shade. Okay, well, let's look at another one. What about this one over here? If I had x on this side, well, this time the big side is pointing toward x, so that's greater than. And let's just keep using 3. So this one means greater than. So on your number line that you're going to drag over, like the number line like this one right here, you're not going to have the 3, but it should look exactly like that with the open circle and shaded to the left. It just won't have the number on it. I'm just picking 3 for an example here. Okay, well, what if x is, let's say, greater than 3? That's what this inequality symbol is saying, greater than. So again, we draw 3 on our number line. And I'm going to pick a color. And remember, we have an open circle again because we can't include 3. We want all the numbers that are bigger than 3. So that would be everything to the right this time, because that's where the numbers that are larger than 3 are on our number line. Okay, so let's keep going. So drag over your inequality symbol that matches that one underneath where you're typing. Well, let's say now I have x. Well, this is still less than. Let's keep using 3. But not only is it less than, but because it has that bar underneath, it can be less than, or it could also now be equal. I don't know why I wrote equal to. So less than or equal to on this one. That's what you would type in. So if we have our number line here, let's just keep going with the 3, just a random number that I picked. So we have our number line. All right. So now we have a circle at 3 because that's marking it. And we know we need everything less than. That's this side over here. But it says, or it could be equal to 3. So because we do want to include the number 3, we would color in our circle for this one. So it's a solid circle, not an open circle. That just means equal to. It means we can include 3. All right, let's go to another one. Let's keep going with X again and 3. Well, this one is greater than, right? This says it's greater than, but because it has that line under it, so remember this line, these are the important pieces, the important new pieces here. The lines greater than, or it could be equal to as well. And so you can think of that line as part of an equal sign. It's part of it. And that means we need to include that number. So again, here we have our 3. So let's draw our circle at 3. But remember, because it can also be equal to, we're going to color it in. And then I want all the numbers that are larger. So actually, this little line underneath our symbols here can be a huge, huge piece in getting a question correct or incorrect, especially when they're asking you to look at the graph of the solution. And we'll keep hitting on this all throughout the year, but it's really important just to remember that if it has the line under it, it can be equal to, it includes the number, so it should be solid, colored in. So let's look at some examples. Now that's how to graph solutions. That was a review of how we graph some of these solutions. Let's look at some examples. How do we actually solve these? So look, this looks very much like an equation, except instead of an equal sign, now I have an inequality symbol, and this is less than. So we still follow the same steps as we would to solve an equation. We're going to draw our line, but now we're going to draw it over our inequality symbol. Well, I need to get my variable by itself, and here's my variable over here. So we could follow those same steps. Draw a line, look for parentheses. I don't have parentheses. I don't need to distribute then. Combine like terms on each side. Well, I don't really have any terms on either side to combine. There's nothing that's alike. So get your variables together. Well, it is, because I just have x in one spot on one side. Now I just need to solve. So if I want this 10x by itself, I could add 8 to both sides, and that will cancel that piece out right there. And that's what I need to do. And then I know that 2 plus 8 is 10. Well, instead of bringing down my equal sign, I'm going to bring down my inequality symbol. And I'm left with negative 10x. Okay, so now what I need to do is I need to get x by itself. So normally what would we do? We would divide. But what are we dividing by? Negative 10. So whatever number's in front of x. So now I'm only left with x. And 10 divided by negative 10 is negative 1. Okay, so here's the big piece that you have to remember. I said if you multiply or divide by a negative at any point when you're solving an inequality, you've got to flip the symbol. That is so important. That is the only difference. Everything we've done up until this point has been exactly like solving equations. But because this very last step down here, I divided by a negative, I now have to take my symbol, what it was originally, and I have to flip it the other direction. That's the only rule. That's the only thing that's different. You have to remember to flip your symbol if you multiply or divide by a negative at any point. Now, it's not when you're adding, it's not when you're subtracting, it's only multiplying and dividing. Usually, most of the time, that step comes at the very, very end. It's the last thing you're going to do, most of the time. It's the step at the end when you multiply or divide. We're going to see an example right here that we're going to be multiplying by a negative, but we don't actually need to flip our symbol yet. So it's when you multiply or divide and divide negative at the end. I'm going to confuse you guys if I don't. Let me stress that. It's at the end is where you're going to be multiplying or dividing by a negative. So here's number 2. Now on this number 1 and 2, you should be writing this on paper with me. So you should have your scratch paper out. And if you haven't done that, pause the video and go back and do number 1 and write it on your paper, because you're going to take a picture and you're going to upload it into your slides. Okay, so here, negative 2 times 3 minus 2x less than or equal to 8 times 4x minus 2. So let's look at another example here. You know what I want to do first? I want to go back up and I want to graph our solution up here of x is greater than or equal to negative 1. So here's my number line. I'm going to put my mark, and I'm just going to put number 1 on that number, that negative 1 on that number line. Remember, you don't have to write all the other numbers around it, guys. just mark where number 1 is. That's good enough. Okay, so there's -1, so I always draw a circle at -1. And this one's telling me that x has to be greater than -1. So that's all the numbers on this side. There's a graph of my solution right there. Now, the question is, do I color in my circle? Well, do I have a line underneath my inequality symbol over here? Nope, there's no line, so I have to leave my circle open because it can't equal -1. I'm not going to include -1. It has to only be the numbers greater than. So there's a graph of that solution. Okay, so now here we go. Let's solve this one. Let's draw our line. So here's what we do. We need to, first step, look for parentheses, and we have them. So we have to distribute here. So we have to multiply -2 times both pieces. Now, I know earlier, I just said in the video, at any point if you multiply or divide by negative, flip your symbol. And that was, I should not have said that like in that way. It's at the end when you're getting x by itself. That's when you're going to flip your symbol. Because right now we're about to multiply everything in parentheses by -2. We don't actually need to flip our symbol yet. Okay. It's actually when you're multiplying or dividing both sides by something. So because we're only multiplying on one side by this -2, we don't have to flip our symbol. But if we were multiplying the other side by -2 as well, like to get x by itself, then we would need to flip our symbol. So you don't actually need to flip it here. It's going to be that last step at the end, where if you multiply or divide by a negative at the very end, then you need to flip your symbol. Okay, so let's do our distributing here. -2 times 3 is -6. -2 times -2 is a positive for x. So I'm just going to bring down my inequality symbol. Now I'm going to distribute on this side. 8 times 4 is 32x. And 8 times -2 is -16. So now the next step says combine like terms on each side. Well, if I look at each side, I can see I don't have anything that's alike on either side, so I don't need to do that. We'll get my variables together. That's my next step. Because I see that I have x over here, and I have some x's over here. So we just need to pick which side do you want your x's on. It doesn't matter, but you need to cancel them out on one side. So I think I'm going to keep my x's on this side over here. So I want to cancel out my other x on the other side. Well, that's +4. So I know that if I subtract 4 x's, those are now canceled out. But I got to do it to the other side as well. So -6 less than or equal to 32 minus 4. Well, that's what? 28 x's. And I'm going to bring down my -16. Okay. Now, same steps as solving equations. Get your variables together. Did that. Check. Now, the next one is solve. Okay, so I want this piece right here by itself. I want x all by itself. So I need to cancel out what's sitting next to it, and that's the 16. So if I add 16 to both sides, oh, yep, those cancel out. That's what I wanted. I'm still left with 28x. And then -6 plus 16 is +10. I'm going to bring down that symbol. Now what I'm going to do is I got to get x by itself, so I need to divide by whatever number is in front of x. It doesn't matter what the number is, just divide by it. So that leaves me with 1x. Here's my symbol. And then 10 divided by 28. So that's a fraction. Don't give me that as a decimal. Just leave it as a fraction. Just simplify it. I know this simplifies to 5/14. Now, if you're not sure how to simplify that, then just type it in your calculator. Type. Oh, what am I doing, guys? I was trying to rewrite that because I wrote my 5 all funky, and then I just didn't do a very good job. See, Miss Robinson gets crazy sometimes too. So type 10 divided by 28 in your calculator. Hit enter. You'll get a decimal. Convert that back to a fraction. Hit math, enter. And then it'll give you the simplified fraction. That's the easiest way to do it. So this is our answer right here. X is greater than or equal to 5/14. Now, I mentioned earlier that you can read these from both ways. Did you hear me? I just said X is greater than or equal to 5/14. So most of the time on a test, they always put your variable on this side. And we can do that. We can flip this around and read it the same way. It means the same thing. But when you do that, you can't write your symbol the same way. Nope, that's wrong, okay? When you do that, you have to be sure and flip your symbol around. If the big end is pointing towards the X, it needs to stay pointing towards the X so that it reads the same. But you can read these statements from this direction, from right to left as well. X is greater than or equal to 5/14. So now all I want to do is I want to graph our solution here. So I'm going to draw my number line. And I'm going to put a mark, and I'm going to make that, this is where 5/14 is on the number line. You could put some values around it if you want. You could put like zeros over here, and you could put 1 over here. That's fine. It doesn't matter. But we're really concerned with what's happening here at 5/14. So I have my circle, and I see that I need all the values because X is greater than. So the solutions for this inequality, the values I could plug in back up here at the top for X in this inequality, and this statement would still be true, are any numbers that are actually greater than 5/14. So I'm going to color all those in. That's all these on this side of my number line. So any value that's bigger would work. But it also says equal to. So I need to make sure and color in my circle because I can include 5/14. I can plug it in and it would be equal. Now on this one up here, I could plug in any number bigger than -1, any number greater than -1. But notice I didn't color in my circle because it wasn't equal to, which means that I actually cannot plug in -1. That would not make this statement true up here. This one up here, right here. But down here, we could actually plug in our value, 5/14, and it would make this statement true. So again, solving inequalities is a lot like solving equations. The steps are very similar. However, you do have to remember at the very, very end to flip your symbol if you multiply or divide by a negative. Now, this one right here, we divided by +28. So because we divided by a positive, I didn't actually need to flip my symbol. Notice I kept it the same until I rewrote my solution. But again, this solution is the same thing as this solution. So I didn't actually flip the symbol and change the way I would shade over here. I'm still shading the same direction. It's still X, and I wanted everything greater than 5/14. So that's why I shaded on this side. Even this is saying the same thing. X is greater than 5/14. So I'm still shading on the same side. I only turned my whole solution around there. I didn't flip the symbol for my final answer. Okay, so remember, it's this step at the end right here. If you're dividing by a negative, most of the time we're dividing. Rarely, sometimes we are multiplying, but most of the time we're dividing. So it's this step right here. If you're multiplying or dividing by a negative, that's where you need to flip your symbol. And that's the only thing that's different about solving inequalities versus solving equations. So your next activity is actually going to be a Desmos activity. So let me get over there and I'll show you what you need to do on that. Okay, so for this activity, you are going to, it's a Desmos, so there's no submit button at the end. You just complete it as long as you log in with your Google account. When you go to the link in Canvas, it's going to bring it up and ask you to log in with Google. So do that and it will save your progress. You can come back to it if you don't have time to finish it, and it actually saves it. And then I can see you while you're working, and then I can see it at the end when you're finished as well. So it says to group your cards on the next. So you're going to have 3 cards in each stack. You're going to make stacks of cards. One's going to have the words, one's going to have the actual algebra, and then one's going to be the graph. So let's look. So you have all these piles here. So you would look for the ones, see, and to group them, if they highlight blue, it groups them together. We did one like this earlier too. So there are a lot of cards, so you're going to have to look for them. So I'm looking for one that says X less than -2. So I can see right here, that's this one, X less than -2. So if I pile those up, it's got 2 cards in that group. So now all I need to do is find the graph that matches it. So I'm looking for one that's at -2. And I also can tell right now by my symbol, because I don't have the line under it, it's going to be less than with an open circle. So I know it's got to be one of these with an open circle. And because it's less than, I know it should be shaded this direction to the left. So I'm looking at all of my ones here until I find one that's shaded to the left. And if you group them together, that's okay. You can just pull them and it'll ungroup them like that. Less than, what about this one right here? So it's shaded to the left. It's open circle, so we don't include -2. And right smack between 0 and -4 is -2. So that's that one right there. So that's how you're going to group them. So this is complete. So then you would go to another one. You would find the words. X is greater than. This is X is less than or equal to 6. So that's what the word you're looking for. And then you would group it with its graph. So you'll have several stacks when you're finished. I think there's 8, maybe 1, 2, 3, 4, 5, 6. Yeah, you should have 8 stacks of 3 cards when you're